Okay, so today we're going to be discussing the concept of if statements. Those apply. Those are conditionals, and then booleans. So your last two lectures, you covered the basic data types in terms of a couple of numbers, like an integer for storing whole numbers, like 1, 2, -2, that kind of stuff. We also covered floats, so half values, decimal values, so 1.5, 9,000.2, that kind of stuff. So you also looked at methods. Methods are nothing more than taking a bit of code that you're probably going to write a zillion times or maybe 2+ times, and just taking the surrounding little bit of code, wrapping it up inside kind of a template, like a little module, and sticking it off to the side. And then where you would have done that in your code somewhere, you just call that method and you feed it customized arguments.
Kind of like a prefab in Unity or something like that?
Basically, exactly the same general concept, yep. So in the lecture notes that I prepared today, I'm actually going to go through and do this lecture is going to cover a lot of if statements, a lot of bools, a lot of the conditional operators that we use both for math and logic. We have a couple of halves to this thing. One half is called arithmetic operators. That's usually doing the math. The other side is logic operators. So as I go through these things, you'll see, and I'll point them out as far as which one's doing what kind of comparison. The knowledge that you've gained up until this point using the integer type, the float type, and then methods, those are very useful in different cases for storing different types of information. And this stuff is it's totally customizable depending on what kind of problem you're trying to solve, what kind of game or feature or whatever you're trying to design. So every so often, you run into a scenario where you don't necessarily need an integer or a float to store anything. You just want to be able to say, is that light on or off? Is that door locked or not? Is that system enabled or not? In that case, yes, you could technically store that general concept inside a Boolean or an integer, 1 being turned on, 0 being turned off. Generally speaking, if it is a 0, it's also referred to in some ways as a null. It's also basically false. Anything other than 0 is true. 1, 0.1, -1, any of those things, they're all true. So when we want the most simple data type that we can possibly have to store these things, these on or offs, true or falses, we drop down to a Boolean type. Let's see here. I'm going to real quick run through for anybody who's like watching this and you want to go through and see what and pause on each one of the slides. But as I go through the lecture, I'm going to cover every one of these things in kind of a flow through code. So we're going to be discussing the if, else, if, and else conditionals and how those things actually operate. We're going to be looking at the Boolean built-in data type. We're going to be combining the information that you learned up until now using integers, floats, and methods, and we're going to kind of take these 5 different things and squish them together and do different kinds of logic. I'm going to show you a couple of features that can be used to invert whatever the current value is, to actually check for its opposite. Let's see here. And then we'll get into the comparison operators, logical operators. That's the comparison is like the arithmetic stuff. So is something greater than or less than something else versus equal to, that kind of stuff. So this is just a quick review. You, per Monday and Wednesday's lectures, looked at, in this case, this would be a definition because you're going to both create the type, give it a name, and give it a value. A declaration being just these first 2 bits, a definition being the full thing. Like, think about it. You look up in a dictionary for definitions. That's the word and the value. So here, I would be looking at a definition, int in age equals 37. If I later on, elsewhere in my code said in age equals 55, that would be an assignment. Notice I left off the word int, the keyword int, because int in age would have existed prior. It would have either been declared or defined. So then we came through, we talked about some strings using the built-in methods. In this case, it's log. Remember I said a second ago we had methods being like little templates, little snippets of code. In this case, log, you're not there yet, but log is a class that contains a bunch of stuff. Think of it as like a container. It's got a bunch of stuff built into it, a lot of functionality. It's got its own variables. It's got its own methods. In this case, log is a method that's built into the debug class. So we can call out to it, and it provides us the built-in functionality to just print something to our console. So when we call debug log and then give it something, the version of log that we use actually has some real nifty bits of power behind it. It can actually understand if you're giving it a number or a string or any of these other different data types. The way it's written behind the scenes is it actually can convert this information. So if you remember in the previous lecture where Justin went through and used something like quote, my age is, quote, and then plus some number, and in this case maybe like in age. Behind the scenes, C#, .NET, all that stuff is looking at what you've written and says, okay, I understand how to concatenate both a string and a variable type and then turn it into something that debug.log can actually understand, and then it dumps it out to the screen. One second. Yeah, you can. It's worthwhile to keep in mind that debug.log is usually primarily for diagnostic purposes. Now, as you go through the test 1.3, the fix me, the other test 1.3, and then the week 2 project that you're going to be working on, we are basically exclusively using debug log there, simply because we've stripped away all the fancy stuff. We're not giving you any kind of like fancy UI and text fields and that kind of stuff to work with. So the most, as Justin said in one of his previous lectures, one of the very first things you do as an engineer or designer or whatever, if you're going to make a new system, no matter what the language is, no matter what the operating system, etc., if you want to start working with it, you want this thing to talk to you. You want to be able to talk to it and have that two-way communication. The very first thing you typically see is a hello world of some kind. You make it give you, feedback. And from that point, you've basically got full control over trying to find out why it's not doing certain things. If you can get it to alert or log or dump to a console or something like that, then you can start hunting down various errors. You can start dumping out your values and see, well, did I possibly have some kind of an issue in my logic? I expected to see the number 5, but for whatever reason it's 6. Why is that a thing? You can go and start hunting down where's the plus happening, where's some other arithmetic happening that shouldn't be, that kind of stuff. So it is very useful. It just happens to also contain some overhead. You don't usually have it in like production games. It's throwing a bunch of information to the console. Your end users probably won't have a console. In most cases, they're looking at an actual screen. So, for early design work, just getting raw information out so that you as the developer can see what's going on, debug.log and some of these other features are definitely helpful, but it's worth knowing this is just one more tool in the toolbox of things you can use to make bend the program to your will. Okay. We talked about these 3 basic data types a second ago. We talked about the assignment. Talk about plus for adding in concatenation. So if you're dealing with just a couple of different data types, just a string and an int, using the plus will actually convert the integer into or the float into the string and kind of squish it all together, and then it gets used elsewhere. You can use these things in different ways. You can actually like take a number and plus a string to it, and it will behind the scenes do the conversion to turn that whole thing into a string. So you can kind of mix and match how these things actually flow, from left to right, right to left, and have it turn into something. Justin also talked about PEMDAS being able to go through and use the plus minus, divide, multiply the parentheses to control order, just like normal math.
No exponents though, right?
No exponents, but we have math library. The thing is, when you look at math, the exponent tends to be that upper little whatever. In code, the only real thing that we have available, because all the other keys are basically used, all the other glyphs, characters, would be maybe the caret. The thing is, the caret is actually used in other languages, also in it's used for different things. So instead of doing that, we typically have math libraries. So if we want to do exponents, that's just power of something.
Right,
so we
get the number instead.
Yeah, so we would basically do something like debug log. We actually have the ability to do, it's either math or math F, it's one of the two, dot pow, as in power. And in it, like log takes in one argument, power can take in two. It's the number and then the power it's going to be raised to. So then behind the scenes, it goes off, it does the math, whatever it's got to raise it to, and then it returns you a float or something.
It simplifies it for you, so you don't have to use exponents.
Yeah, exactly. It's just it's wrapped up, another tool in the toolkit.
If you can get rid of something to make it simpler, that's still the best way to do it.
Yeah, exactly. And so these are as you saw in some of the lecture, the last two lectures, as Justin was writing different things, the words would turn into different colors. They would, as I'm writing out whatever, int suddenly becomes a keyword. There were other words that he was punching in. Partial, I think, became one. These things mean something to the language. C# knows these things ahead of time. Just like it knows what debug log is, and if you called that, it's got a purpose. It's got an expressed intent because somebody wrote it. Somebody who wrote the C# language at some point said int means integer. It's a keyword. It's predefined. You really can't come along theoretically and change it to something else. You can't redefine it. So yeah, each one of those things, they do different things. So we wrap up some of that logic, because as you're working with just systems in general, you find computers like to talk in radians, not degrees. Humans like to talk in degrees. And so you run into math libraries that just have these conversions, the divide by 180, multiply by 180, that kind of stuff. And so just like debug.log and just like mathf.pow, you can call into these things, and it may behind the scenes be doing some crazy complex amount of work, or it may simply return you a single number. For example, pi. If you ask the system for pi, it's probably going to do nothing more than return you 3.1415 and however many decimals it decides to give you. So, some of these things are incredibly simple behind the scenes. Others are much more complex. Like debug log, it's got to tie into all these other I/O systems. But something like pi is much more simple. It's just a single number. It's a constant number. Yeah. Let's see. So I mentioned this earlier, that the basic Boolean data type, if you want to just store a true or false, you drop down to bool. In this case, in C#, we use a lowercase b and then just OOL. Other languages will go with an uppercase B, the full-blown word. In this case, we're just using bool. And using Hungarian notation, which is the prefix for what the type would be. The idea here is, if you're looking at a whole bunch of code and you've created your variable up at the top, you've either declared it, defined it, whatever. If you're looking, a few hundred lines down or one page up or page down outside of where it was originally created, you might not immediately know what that type is. So if I just had a variable called game over, I don't know that that's not necessarily like some kind of a counter of number of times I've game overed, or some kind of a text object that I'm storing, a string that I'm storing something in. So we have this concept in most of our languages. This also applies to the whole uppercase, with each of the variables and the methods, how we define this stuff. It's the uppercases are called camel case, reverse camel case, and Pascal case. The B that you see at the very beginning is called Hungarian notation. It basically means that you've got all this stuff you're looking at as a 2 nanoseconds. Your eyes can see this thing. Your brain can go, that's a Boolean, because the B is shorthand for Boolean. S would be shorthand for string, and N or I for integer, F for float, that kind of stuff. So if you see those kinds of things popping up in our code, don't let it, what is this? It's just
a. Is that something to make a good habit to do?
It. So back in the day when we didn't have things like IntelliSense with Visual Studio, or it was more buggy than it is now, or if you were doing, for example, console development or something where you didn't have the ability to jump into something like Visual Studio, or server development, if you're working through a terminal, you don't have some of these cool fancy tools that colorize your text, that give you, like when you mouse over a variable, it'll tell you in a little pop-up what that variable type is. Yeah. Do what?
Really cool.
Yeah. So IntelliSense and the systems behind the scenes, a lot of these IDEs, in integrated development environments, will do this. Visual Studio will do it. MonoDevelop will do it, et cetera, et cetera. The thing is, in some environments, you don't have access to that. So as an old school programmer way of figuring out what that type is very quickly, we would throw these little 1 or 2 character type indicators at the very beginning of it, and then as you're reading all this code, you could infer what type that thing was.
Or
with
you're handing it over to somebody else to look at.
Exactly. It all ties basically into coding standards.
Right.
Pretty much no matter where you go, no matter what projects you look at, you're going to run into that company or that team or whatever is going to come up with some kind of a design or a coding standards document. And they're going to say, yeah, we use Hungarian notation. Other places don't at all. So in this case, that's what you're seeing here. Yep. And so, in these modern tools, some places have completely omitted it. So your mileage may vary depending on what kind of project and team and company you're dealing with. But that's why you're seeing it there. So the B is not a random letter that I've pulled, like A game over, B game over, C game over. It's not that. It's B as in Boolean. And then if I want other copies of game over, number one, I need to ask myself why. But if it's a game over text, I would call it S game over text or something like that. So I would know, this variable, this method, their names, their signatures are telling me what it's doing. You use nouns and verbs in English, in language to indicate what's going on. We do the same thing when we're writing variables or methods, do something or on whatever, on collision,
right.
That kind of stuff. So we handle those kinds of situations as if they're, as if you're naturally reading.
Right, like in English, you got words that mean the same thing.
Yeah.
Depending on how you use them.
So exactly.
That, right?
So exactly. So you're coding, yes, but you're also understanding what's being written based on the lexical flow of it, like how it was written, and a lot of the stuff will tend to read as if it's logical. And that's kind of the point is, as we write this stuff, we don't generally just arbitrarily name things. We want them to mean something. So the methods, the variables, they mean something in their names.
When you think about it as like in language, it's like got to have a structure,
Yeah. C Sharp, C++, C, any of these, JavaScript, etc. They are languages just like English or any other language is. And so while each one has its own rules, it's also got its own kind of flow and feel. And so, you like as we're writing this stuff, you'll notice every one of these lines ends with a semicolon. Well, in English or any other, some other languages, it ends with a period.
Right.
And so that's our way of saying to the computer, to the compiler, end this line of code. That is a period as the computer understands it.
I feel like that type of analogy is like really helpful. You know what I mean? When you put it in
Oh, yeah.
because those are things that you're already, accustomed to.
Yeah. If like programming tends to be initially like a scary concept,
Right.
but once you realize this is nothing more like, as adults, we learning another language, be it this, any other language, spoken language, written language, that kind of stuff, we don't really remember what it was like for us to learn our first language, the difficulties. And so just getting over those humps once you get to that point and you realize the similarities. And these are the basic things. This class is called, Programming Foundations, because these things, these data types, this concept of methods and the hello world stuff, these are foundational to pretty much any language, no matter what system it's on, no matter what language it's written in. So once you've grasped these things, then you can pretty much, once you learn the nuances and specialties of some other language, you theoretically can jump in and hit the ground running.
Right.
So I mentioned earlier that we had up to this point integers, floats, strings, and then today we were going to be looking at booleans and if statements. So the computer, by its nature, it is computing. So it's internally making decisions. If this was something like a high-level game, let's say you're, Doom, whatever. You're walking through the scene, you walk up to the door's locked. You don't have a key. The game logic is saying, do you have the key? The answer is no. So then you have to go find the key. So when we develop these systems, when we design these systems, we're doing a lot of decision making. These computers, these programs are basically acting like, in a certain way, like the human brain. If I walk up to that door from the outside and it's locked, my next step is either one, to knock on the window or go find the key. If it's open, if it's unlocked, I can just open the door and come in. So the computer is doing basically the same thing. We represent those decision points in what are called conditionals. The if statement basically says, if the door is open, if the door is unlocked. If we have the key, we can thus unlock the door. So the way we put these things together, these lines of logic, of checking logic, they can be very simple, from checking just a single variable. In some cases, you don't even need the variable. You can just write in the word if true or if false, just to basically force the code to do something. But generally, we don't like to hard code stuff. It's not a good technique in programming. So what we'll do is we'll use our variables, those integers, those floats, those booleans, those strings, and we can then query those things. We can ask them if they are equal to something. Or if we were doing some kind of math, for example, is 5 greater than 4? True. We can use, and that's, earlier I said I'd talk about the arithmetic operators and the logical operators. We could say, is this thing true, or is this math going to resolve to something? The key word to take away from all this stuff inside these if statements, they are conditionals. They're going to test some condition. The stuff that's inside the parentheses, and I'll get into the individual parts here in just a second. The stuff that's inside the parentheses, at the end of it, once it's all taken care of, it is what's called resolves to something. It becomes some answer. And the question is, does this clump of logic resolve to true or resolve to false? At the end of the day, you can compare math, you can compare strings, you can compare booleans, doesn't matter. At the end of it, it's either going to be true or false. And so, using some additional symbology here in just a second, you'll see, we can tie this stuff together. So I can ask the system if this string actually contains information, and if some bool is set to something, and if some number has reached some particular value. So I can chain these things together, but I can also ask the system, if both scenarios are true. If that door is locked and I have the key, then I can unlock it. If that door is locked or it's not unlocked, which actually doesn't really make sense, then I can enter. Without the key, I would have to find a key and unlock it. But in any case, so you can ask these things for all of the conditions that you're testing for to all be true. You can optionally say, well, at least some of them are true. One side or the other. You can kind of bounce back and forth. But you can also take this logic and whatever it resolves to, and even before it resolves, like as it's calculating inside the parentheses and that kind of stuff, you can actually flip this stuff over. You can invert how it's looking at it. Generally speaking, if the if statement is true, whatever's inside those parentheses, if it's true, the very next line executes. But you can flip that. You can ask it if that thing is actually equal to false. Then it won't execute this, or then it would, if it was false, would execute the stuff inside it. But you can run those different kinds of tests. And so here in just a second, when I jump into actual code, you're going to see a number of these test scenarios where I am checking for false conditions. I'm checking for true, but then I flip it.
Is that like used so like you don't have to write false statements, or like how would that like? Trying to think of like what the applicant used to do. Like if the door is locked.
If the door is not locked.
All right, yeah, like if the door is locked, you can come in. If the door is not locked, you can come in. If the door is locked, you can't come in. Mm-hmm. So you wouldn't have to write both. You just have to write one, or.
Well, so in that particular case, because there are two possible scenarios, either the door is locked or isn't locked, you would, as a designer, think, well, if it's locked, I probably need to go find the key, or I need to check my inventory to see if I have the key. Right. So like up here, you're seeing at the top it says if the condition is true, but then right below that, in the next little section, it says else. There's one more that uses those two words together. It's called else if, which if the very first if fails, the next line could be an else if. It's a secondary check. You could add a third, a fourth, a fifth, and say, if this first one fails, if the second one fails, third one fails, fourth one fails, the fifth one might succeed.
Like, is the inversion used basically for just testing things?
No, it's used live in all kinds of code. You can use it. Basically, this is what we're showing you here. Their use cases can be completely unique to whatever problem you're trying to solve. When you're looking at like the door example, or do I have the key in my inventory? I might have a red key, but I might not have a green key, and maybe that one particular door requires both. I can do, maybe it's one of those scenarios where, if I have turned the valve off, but I've not pulled the switch, I've not pulled the lever or whatever, then I can ask the code, wherever in my code I'm storing these variables and whether or not I've interacted with them, I can ask, has the valve been turned? True. And has the lever not been flipped? Then, maybe like some special trap secret door opens up.
Okay, so for more than just one scenario, there could be multiple scenarios.
Oh, absolutely.
Right,
yeah,
this outside the box there.
Yeah, like I said, these kinds of things are basically like the human brain. The human brain, if you go all the way down to the lowest levels, it's doing a bunch of these things. Right. And so while this is incredibly simple, mapping of just conditionals and if, else statements, your brain is doing the whole neural net, and it's doing these kinds of calculations live. We're just doing them at such ridiculous quantities that we appear to be thinking conscious sentient beings, whereas here it's a brutally straightforward one single is it true or false, tie a zillion of these things together, and suddenly you've got something like Cortana, or I mean like Halo Cortana, not Microsoft's Cortana. Right. So you get to these levels of artificial intelligence that are Turing machines. You get indistinguishable results from a human being. So you start tying these possible conditions together, and your brain is asking those questions. If the door's locked, then I need to either knock or go find the key. A basic, simple AI could do that exact same calculation with just a handful of lines of code. So we then go extra steps and say, well, I need to walk to the location to get the key.
Right.
My heart still needs to beat. I need to monitor for people around me, sensory perception, all that stuff.
Right.
So we have a lot more stuff going on than something simple like this. But at its most basic foundational, layers, that's all that's going on.
Yes or no, right?
Exactly. So let's see here. So we can, yeah, exactly. As these things get more and more complex, you do get, and what was it? Descartes, I think, the old.
I think so. I am right.
I believe so. It's the old. It's the old. The name has been modified over the years. It used to be like the evil demon problem, or the brain in a vat problem, or the am I living in a simulation. It's basically the concept of the movie Dark City and The Matrix.
Right.
When the system becomes so technologically advanced that you, like I said, the Turing machines, that you can't distinguish. This is the whole conversation in modern day that Elon Musk is having. Are we possibly living in a simulation? Well, if the simulation's good enough,
right,
you can't distinguish it. That's one of those, interesting philosophical, thought experiments.
Right, like a perfect virtual reality world. How would you even tell the difference between them?
Exactly. Right? 100% exactly. So as we go through and we write this kind of logic, it's the old, in the Thor movie, it's like a civilization sufficiently advanced, that technology would look more like magic to lower civilizations. So it's indistinguishable at that point. So you end up, but once again, at the most fundamental level, no matter how wild and complex it is, out there in the solar system, out there in the galaxy, etc., universe, those things that are going on, the black holes, this, that, and the other, it's all, yeah, exactly. Einstein's equations, or Feynman's diagrams, like all these different things that you can research and see how, like the Large Hadron Collider, like all this stuff at its most fundamental level is this kind of stuff. Exactly. And so, so we can do certain kinds of tests. We can flip these tests around and ask different questions and get different answers. So we basically customize, we tailor what we're writing in code to give us certain behaviors from our programs. So
like inverting like a series of like true statements, you got like 10 of them, whatever. If you change a false down here, what's going to happen all the way up here? Like
exactly.
So you can see all that happening. Right?
And the interesting thing about the way if statements work is you can actually short circuit them early on. The idea is, as I'm testing for individual conditions, as this if statement grows, I can actually say, like, if the very first, because this stuff is calculating from left to right, you could say if the first value is false and everything after that just doesn't execute because the very first thing said it was false, it's done.
Right.
So the and condition that we're going to get into here in just a second couples these multiple pieces together. I said earlier you could, ask a string if it's a value, ask a float or an int if it's got a certain number, ask these different questions. Well, these questions, they all get linked. They get kind of like the concatenation stuff, right? Except instead of plussing together numbers or plussing together a string and a number or a string and another string or whatever, we're plussing together logical questions. So you can ask it a question and you can say, well, if this side or this other side. You could also ask it if this side and this side. If the door's locked and I have the key. If the door's not locked and I have hands or whatever to open the door, or whatever. The scenarios are infinite that you could probably come up with for answering these kinds of questions. But the idea is, because of the way this stuff checks, yeah, exactly. You can get really detailed with these kinds of questions. And so the idea being, because of the way this logic runs, I said earlier that it resolves to something. If the very first thing resolves to false, and the next thing connecting the first part to the second part or third or fourth or whatever in number of times, if that is an and, it can actually short circuit the way this thing works. So it can basically early out. It can abort the decision making because no matter what you've written after that, it is guaranteed from the very first thing saying false, false, and, well, none of that stuff's relevant.
Right.
If any of this stuff is true, it doesn't matter because the first thing is false, and. So using something like false or, you could, one of those sides, remember I said the if statement has to resolve to true before the stuff inside it'll work. So you saw a second ago where we had the if, else if, and the else. If the logic that's inside either the if or the else if either of those at any point they're false, then we tumble to the next thing. We chain these operations together. It's a guaranteed, I'm going to try the first thing, and then I'm going to try the next thing if the first thing failed, and then try the next thing. And so when we use the word if, the keyword if, we're doing some kind of a check. Doesn't matter what it is, it's just some kind of a check. So conditional, 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 going top to bottom. But at the very end, if none of our previous statements have returned us have resolved to true, and we can do some kind of logic, then we have the option of having a default scenario. Like if none of the scenarios occurred, then do something else. And that's where the else, the single word else, there is no if applied to that. It's not else if, it's just else. It's a default. And so we could go through and say, if the door is locked and I don't have the key, then I can't get in. But if the door is locked and I don't have the key, else it could jump down to the, hey, you need to go find the key. These are rules that we can build into our games or whatever system we're building that can basically inform the user or other systems. It doesn't even have to be the user, the person playing the game. It can be my game manager might be asking the inventory, do I have something? And if it returns back the else, the default condition.
Does the inventory have a key?
Yeah.
Are you checking your inventory?
Exactly. So it could just tell me, I don't have the information you were looking for, record not found, that kind of stuff. So you can kind of see that here with the else for the light being turned off. If it's not true, then it's obviously false. So it drops down the default condition. You'll notice that else doesn't have any kind of conditional. The else does not have an if the light was some other third state. We're not dealing with quantum mechanics here. That light can't be on and off at the same time. We're not dealing with qubits. So I mentioned earlier that inside our if statements, we're always looking for the thing to be true. But we can also ask it if it is false. We could say, if, and then this variable or whatever, equals false. And if it is equal to false, that will become true. So that would make that first statement execute whatever was right underneath it.
Why the two equals?
It's a comparison. Remember in the integer and string and float operations that we've been dealing with so far, the definition and assignment, 1 equals. We're saying something equals something. Here, 2 equals is a comparison. So we excuse me, we ask it if something is equal to something else. So, think about it as 2 syllables is equal, or 3 syllables, whatever. So if you see the 2, and the compiler, Visual Studio, Unity, if you accidentally write one of these things as an assignment or as a comparison and you didn't intend to, you meant for it to be an assignment or comparison, and you wrote the wrong one, it'll warn you. As soon as your code, a Visual Studio will say, hey, this code probably seems wrong. It'll give you, yellow or red squigglies underneath it. Yeah, and if you've saved it and compiled it back in Unity, Unity will tell you, hey, you might have used the wrong thing here, and did you intend to do this? Now, remember, there's a slight caveat to that, a little asterisk. Remember I said that whatever was inside that if statement, it's got to resolve to true or false at the end of the day. Well, you can do assignments, and this is more of an advanced topic. You can do assignments inside the if statement, but whatever that, it's usually like inside an extra set of parentheses to kind of control it, like the PEMDAS stuff. We're kind of controlling the stuff inside here. If it's like like in age equals 1, when that resolves, 1, as I said earlier, 1 would be true. So we could do additional checks. Now, when you start adding that kind of, it's not rule breaking, it's just you're using the thing, like I said, in an advanced topic. So when you start doing that kind of stuff, other rules apply. You might have to put more information in there. So that's why I'm not going over it now. I'm just letting you know that
it's more advanced form of what we're doing right now.
Yeah, even though what you're learning now is the basics of comparison and that kind of stuff, know that if you do see code later on after this class, and it's like, well, I thought Tony told me that I couldn't do X. Well, you can, but you'll notice there's extra code in there to make the code behave. Like, you can do assignments that resolve, but then you have to turn it into like the Boolean that it was expecting. Like, if the system might be able to infer what you meant, but sometimes you have to explicitly, like the words there, implicit, it can implicitly figure out what's going on. You might have to explicitly tell it, I want this number, 1 or 0 or -1, to be a Boolean. And you have to do a couple of extra things, but you can do it. But for all intents and purposes, all this basic stuff that we're looking at now, consider, let's see here. We'll look at the symbols here in just a second, the actual comparison symbols. So early on, and by the way, I said earlier that some of these slides are a little out of whack. This is a prime example. Serialized field does not contain a space. Other slides, for those listening in the recording, there is no D on serialize. It's just serialized field, all one word, capital S, capital F, and inside the brackets. So what you're seeing right here, as we're writing this code, we sometimes want to be able to tune this stuff. So either you're going to tune it right there in your code, and you're going to hit save, and you're going to jump back to Unity, let it compile, run, stop, jump back to your code, change it, jump back and forth, back and forth, back and forth. It gets tedious after a while, especially if you're testing large, complex systems. So Unity provides us a couple of different ways to gain access to our variables, like from the editor, from the inspector, right there in code that we can then modify. You're not there yet. It's going to come up in a few more classes when we start talking about access rights, other scripts being able to access other members, other variables inside other scripts. So that later on will be the words public and private. Now, I'm not going to touch those at the moment. I'm just going to show you how you can expose a variable that's hidden to the inspector so that you could possibly change it later on. And this allows you to live change your code, write in words, that kind of stuff. If you take a look at the Scoville scale, it's question number 11 on test 1.3, the first test 1.3. It's going to ask you to replicate the Scoville scale. We'll go over some of the initial stuff here at the end of class, but the ability to go through and change what the Scoville scale is, a measure of heat for peppers. And so the code that we're using to indicate what level of heat we're dealing with in that test will fluctuate. It runs inside update, meaning it's running every single frame. But we want to be able to modify that number. What is our current heat? It's at the lowest level, it's 50%, it's 100%, whatever. To modify that variable, that number, we basically want to expose it. Yeah, we basically want to expose it to the editor so that we can change it live. That means every single time update comes around, it re-queries that variable, looks at the value, runs the calculation using whatever updates have been made. So that's where serialized field comes into play. It allows us to expose certain things to the editor. So in this case, and by the way, B is lowercase there, so yeah. So in this case, we would be able to toggle. If this code was running inside update, we'd be able to flip you would actually see over in your inspector a little field for B game over. And it would be, I believe it's a checkbox, and you could toggle that checkbox. Your code, what's being printed down into the console, would say the game is still running, or the value of B is, and then it would be, in this case, it would be true because the first part is false. It would toggle. So yeah. Yeah, and like I said, these rules, whatever it is you come up with, they can be modified. In this case, false would become true because, so got a little ahead of myself. I said earlier that you could invert some of these things. So you could, even though your variable might be false, and just it by itself would cause an if statement to fail, right? It would resolve to false. You could ask it if it's false. Well, does false equal false? Yes, it does. Yes is true. So you could ask it if it is false, pass that test, and then move on to the very next line. Well, the shorthand for writing out the characters equals false is just the exclamation mark. You add that to the very beginning of whatever your variable is, and it flips the value. So it inverts whatever it is you're dealing with. It's called the not operator. So if it is not true, if it is not false, you can think about it that way. So when we start doing actual math with some of these things, is my life count greater than a certain number? Is my score greater than some value? Etc. We use these operators here between, like inside our if statements, but between a variable and then some either other variable or some constant or whatever. So we can say lives greater than 0, you're still playing the game. Lives less than or equal to 0, you've died, but maybe you're in ghost mode. That kind of stuff. So we can apply these things in different ways to do different kinds of checks. We can, you heard me say earlier we were using the double equals for equality, is equal to. You can also use the not, the exclamation point, the not operator, to say if this object does not equal this other object. You can do your mathematical comparisons. For the top two, greater than or less than, are exclusive. It says if this number is above this other number, but not possibly equal to it. The next two, the greater than, excuse me, the greater than or equal to, check if it's above or below, but also potentially equal to that number exactly. It's an inclusive check. And then the last two I just covered, the not equal to and the equal to. So all of those comparison operators, those are your arithmetic. You're doing math. You're looking at the numbers. You're doing some comparisons. The last two are a little special. They do some other stuff. They can be used on other objects as well. The logical operators. Yeah, sorry, Julio. I jumped back one slide. Now I'm on logical. So earlier I said that inside our if statements, if we want to do some kind of comparison of if this thing and this other thing, if the door is locked and I have the key, then I can check both sides. They must both be true before this if statement will actually execute. So that's what these two ampersands or two pipe glyphs represent. The top two are and, if this side and this other side. The next one is if this side or this other side. So we refer to this as logical and, logical or.
I almost never see that key getting used. That key all the way on the right. I didn't even know
that guy. Those two there?
Yeah.
Oh, it's
never used them before.
It's you mean on your keyboard?
Yeah. On the keyboard,
Well, that's the thing is like a lot of this stuff, it can be used in different ways, but we rarely see it pop up in our normal daily lexicon. Yeah. But it's absolutely it's pretty much critical to the functionality of code, or if you're doing like server script or shell scripting. If you're trying to, you may have heard, I'm trying to pipe the output from one thing into another. Right. That's that key. But it would be a single one of these things. This, just like the equal sign and the two equal signs.
Yeah.
One represents an assignment. The other one represents a comparison. Here, a single ampersand and a single pipe mean something different. Please keep that in mind when you're doing these kinds of tests. If you write in your code a single ampersand or a single pipe character, your code might appear to run correctly, but there are edge cases that can absolutely break it, because behind the scenes, this is a much more advanced topic, but you're dealing with what are referred to as bitwise operations. You are asking it if the internal bits that make up that thing match some value. And that's not what we're checking. We're checking the whole object, if it's true or false. We're doing logical operators, not bitwise operators. They are two completely different things, but there's just enough, Venn diagram wise, there's just enough overlap that the two can kind of masquerade. So please don't make that mistake. You probably won't see bitwise operations in this class or even in this program maybe. Later on, you might get into like, layers. Like, when you're dealing with physics and you're using Unity's editor and you're setting like tags and that kind of stuff. There's an option in there to go through and assign fields. Well, behind the scenes, they're using some of this technology, some of the bitwise stuff. But again, it's not exposed to you unless you really go and you're just further curious. So in this case, we're only ever dealing with the two ampersands and the two pipes, the two ors. Oh, sorry, I missed that last one.
I don't think I've ever used an or statement so far.
Yeah, it's one of those things that it rarely comes up in just regular typing. I mean, maybe if you're, formatting some kind of a block of text to look a certain way, your glyphs. Oh, I like this vertical. It looks like a column or something like that. But yeah, it rarely. Does it even? Yeah, it just rarely comes up in written language, I guess. It's usually in code. Sorry, Julio, I don't know what you mean, simulation stuff. Oh, yeah. Well, the physics engine in general is doing, simulation of real world physics, but it's all game development is all smoke and mirrors. So behind the scenes, it's, does this object interact with this other object? Can my ball interact with the walls or the ground or certain things like that? So you can actually go through, and in Unity, you can say, like, the ground is a certain layer, the walls are certain layers, my player is a certain layer or whatever, and so they can interact or not interact. Unity gives you that power. I think Unreal does as well. Most engines that have physics engines behind the scenes, it's an optimization technique. If you don't need to do physics on something, then don't. It saves you CPU cycles and that kind of stuff. So we just avoid it. By flagging these things with different layers, we can mask them out. They don't run, essentially. Ha, yeah, exactly. So here in a little bit, when I go to conclude lecture, we'll go into the Scoville scale a little bit, and I'll actually break down some more of this stuff. This is basically the question from test 1.3, the first one, question number 11, I think, where it's asking you to complete this thing. We give you the initial framework of the initial skeleton of like the very first values and the very last default condition. It's up to you for that particular question to basically fill in all the rest of them. Now, this scale, excuse me, this scale is a little interesting. So when you look at it and you go to write in these values, if you'll notice the end, the beginning and the minimum range and the maximum range, they actually will overlap. So one starts at like 10,000 and the next one ends at 10,000. Well, when you're writing the code, we're not going to ding you for it being 10,000 and 10,000 and then like a greater than, less than, and using the equals. Just because of the way this scale happens to represent it.
10,000.
Yeah.
Both fields, right?
Yeah, if this was a real world example, a real scenario, then we would be looking at actual range like splits. You would actually have some kind of a line of delineation between range A and range B. In this case, they tend to overlap at the exact value, so technically you're in both ranges at the same time. It's just however the scale was put together. So we won't ding you there, but the idea is to grasp the concept of using a minimum range value check against a maximum range value check. And so the scale has minimum ranges and maximum ranges. And so this very first one, if the heat goes greater than 855,000, that is strictly a maximum range check. So when I write this here in code in just a second, you basically do the same thing, but for the rest of the scale, which actually is that right there. So it's a minimum range check and a maximum range check. In this case, it's actually flipped, so it's maximum on the top and then minimum on the bottom. But the idea, notice we're doing a comparison of two values against two constants. In this case, our heat value of 350,000 or 580,000. And then we're saying as long as we're within this range, that would be our double ampersands, then it's your funeral. We're in that particular condition. And so we chain these else ifs together for all the different layers, all the different ranges, and then we basically just do the individual responses for every one of those layers. This would be at the end of lecture, and then after I do that, after I show you the Scoville stuff, I'll move on and we'll actually take a look at the fix me. I'll give you two of the real quick fixes there, and then we'll adjourn. Okay, so I'm going to open up Unity. Yeah, basically as long as you paid attention to what's written in the fix me, because that test has such a low weight and such a small number of things to fix, it's an all or nothing. If you fix it, cool. If you don't, if you mess up one of them, it's a 0. That's how it works. If you've paid attention, you understand what these first 3 lectures worth of content represents, the individual comparisons. And again, if you read what it says in the code, it tells you exactly like how to deal with this stuff. So it's, for all intents and purposes, it's an open book test. And in most cases with open book tests, it's pass or fail. So I've already just real quick created a lecture project. I called it Day 3. I believe you can continue working out of the one you did for Monday or Wednesday. If not, just do new, name it something. 2D or 3D doesn't matter. I don't want analytics, and put it somewhere, and then hit Create New or Create Project.
So we could still use like the first one, like when we did October lectures.
Do you want us to do that right now?
If you don't already have it up. Yeah, basically what I'm about to write here, now mind you, all this stuff is recorded, so you can reference back to it, but for muscle memory and practice and that kind of stuff, I'd recommend you do this and actually follow along. There was another question. If we could continue working out of the Day 1 or stuff.
Can we use this? It doesn't matter what file we use. Like I have October lectures one that had the original first day stuff on it.
Show you. Yeah, just create a new script down there in your project directory. Hit create. Yeah, the only, so I've mentioned this online a couple of times to different people asking, and I'll just say it just right out. All of our lecture material, you could put it all in the same project in different files or whatever. The week 2 project, the week 3 project, they need to be in their own isolated projects because of cross-project contamination. We're doing stuff that's so different in the week 2 and week 3, we don't want extra stuff in there.
So just change weekly, is what pretty much you're saying, like one
Yeah.
project for each week?
Yeah, exactly. And so the lecture stuff, the only problem with dumping all of your code into a single lecture project is if let's say you've experimented, you're doing the exercises which don't get turned in, they're just for you to experiment with. If you're working with us, you're trying to follow along, maybe you've fat fingered a key and you've added an extra symbol, or you've injected some kind of a compile error, or you're experimenting with the exercises and you've just not completed it. Any of those bugs, Unity sees all of your files as one complete project. So if you've got a bug in your day 1 lecture stuff and you're trying to work on day 3, Unity will not let you compile. It will not let you attach that script or continue working until you've resolved the original bugs. Your project has to be bug free, otherwise it complains. Sorry? So there's a couple of different techniques. You can use block commenting to comment out the entire script. You can use pound if false at the very top, and then at the very bottom pound end if to turn off the entire file as well. The problem is, when you say turned off the file, if you've either not had it attached to a game object, or you have it attached but you hit that little checkbox to turn that component off, that code still exists. That code is still seen. As long as that code is seen and can be compiled, that's what Unity cares about. So using those two techniques I just mentioned, you can basically turn off the contents of the file completely, and then it's not seen by the compiler, and you can move on to other files. The other option, besides creating whole new tests or whatever, is to just, in your project directory, right-click and go to Explorer and just physically move that source code out of your project. Just dump it on your desktop or make a folder or something like that. Just get it away from Unity's eyes. If Unity can see it, Unity's going to try to compile it, and that's what will screw you up. So as long as everything is isolated, clean by comparison to the other files, then you're pretty much good.
I learned that hard way last month when I was taking, with one of our projects, we started moving to an API.
Mm-hmm.
Started shifting everything from one thing and started changing a whole bunch of code. And one of the things just had a completely useless script that was calling references from the one I was working in.
Mm-hmm.
And just started getting a whole bunch of errors. It's okay, I'm done with this. Save, go into Unity, click play. The script's now yelling at me. Went in and just commented everything out. I was like, screw this, I don't need you anymore.
Yeah.
You're just for reference.
Yep. It's unfortunate because Unity in an older version had a specific folder specifically for the web player, which you could put troublesome files like that in, and it just wouldn't see it, wouldn't compile them. But they've since removed the web player as it existed back then, so that folder no longer exists. So you just have to comment out the file in one way or another, or just remove it from your project. Yeah, I'll get into the with regards to the fix me. You're going to want to create a new project. You're going to want to pull in that file. Again, it isolates the fix me alone from all the other stuff that you're working on. When we get to actually doing that towards the end of class, I'll pull it in. I'll show you some of the different things, and then it's basically up to you to continue on because, again, that's a test. Okay, I'm going to close this or minimize this. Jump over to my Unity. I'm going to create a new C# script. Just going to name it day 3. Okay, so I can start. Let's see here. I've got some notes of just different things that I want to cover. So like I said, the if statement handles conditionals. It the stuff inside the parentheses resolved. And I said I'd show you the actual layout here. So the code itself is basically it's basically 3 parts. The most simple that you can write is if parentheses, and the logic that goes inside the parentheses is what becomes true or false. So just for demonstration purposes, and I said you could do this earlier, so just true. At the end of it, we drop down a line and give ourselves an open and close curly bracket. And here I'll do debug log first if, whatever. So save that. Jump back to Unity. I'm going to create just a default object over here in my scene. Null really doesn't matter in terms of positioning. Again, as Justin said, don't really worry about this this warning about inconsistent line endings. It's just the different operating systems. So I'm going to take my day 3 script, I'm going to drop it on, and if I run this, let's see here, console right here, first if. Okay, so now if I go back to my code and I change this to false, save. Actually, so this is going to get a little messy, but what I'm going to do is I'm going to keep writing this stuff. I'm just going to turn off the stuff that I wrote before. That way you can use it as a reference if you want to look at it further. So I already got this first little block. I'm going to go ahead and copy that. And don't know what that was. So I said a second ago that if you happen to have extra files that you wanted to turn off, you could either block comment using a / ***, or use a pound if false. Now, you saw in last lecture we used these 2 / here to do a single line comment. There's another technique that you can do for just a single / asterisk, and notice everything else after this line shuts down. It goes into commented mode. I can do the same thing at the end of one of my other lines, but I invert it, right? So I use asterisk / and now everything else after this line comes back. I have effectively turned off this little block of code. It's not going to get compiled at this point. Now, if you needed to turn off the entire file, you can do that same thing to the entire file from the very top to the very bottom. But I'm actually going to I'm going to show you that other technique just real quick. Oops. So at the very top, pound or hashtag, whatever, if false. Notice how the coloring of everything after this changes to like gray. It's completely disabled. But I'm getting errors down here at the bottom. Expected this directive, pound end if, because I'm ending an if statement. This will effectively, I'm basically quarantining this file from the rest of the system. So using those 2, ahead of compile time, I actually tell it, don't do anything with this file. There's no content whatsoever. So I can, come back up here and turn it all back on. So that's just a little, thing that you could use if you were so inclined. We don't really tend to use it all that often, but it does come in handy. It's an extra. Like if I in my code had something like this, if I came up to the top and I tried to turn off the code using that same block comment technique, notice it didn't turn off all this code after it. That's because it technically sees this closing as the end of the very first one. So, 2 different techniques to turn it off, to turn off other code. So anyway, and Visual Studio is going to try to format some stuff for me every time I paste. So bear with me while I fight it. So in this case, I've turned off this code that we saw just a second ago. I've duplicated it, but in this case, I'm going to use false. And like I said, if the false does not resolve, or sorry, if the if does not resolve, it won't run the code. And you'll notice Visual Studio is already telling me right here with debug, if I mouse over this, unexpected code detected, or rather unreachable code detected, meaning it already sees that it can't reach this code. So, hey, there might be a problem here. Now, if I jump back to Unity, let it compile, I should receive a warning basically saying the exact same thing. And if I play, I don't get any messages. It's because I don't have any active code. So you can turn things off like that. Now, earlier, I said you can do comparisons and kind of invert the logic. So here, if false is equal to false, then that statement becomes true. So I can save, jump back to Unity. Notice I no longer get that warning. I no longer get the warning here. And if I run, I get that statement printed out again. Okay? And the same thing, if I get rid of this, and this is for, whoops. This is for the notes. Like I'll leave the equals false on there. I'm not going to duplicate this line. I can also use the exclamation mark to indicate an inversion of the logic. I can say what's not false? Well, the opposite of false is true. So save, jump back to Unity, and I should get the warning because this code's true, so it'll work. So there it is again. Okay, so that gives us the basics of an if statement. Now, if I wanted to do additional checks, that's where the else if something. So in this case, let's just force it to be true. Debug.log second if. And I'll go one step further, and I'll throw in the else. And notice, after every one of these statements, and if you'll notice as within the file as a whole, you'll see these curly brackets in different spots. Up here with the public class, you see a starting one, or a left one. Then you see another left one here with start. Every one of these if statements starts a left and closes a right. Starts a left, closes a right. Starts a left, closes a right, closes a right. This close right, if you put your cursor right there on it, you'll notice that it highlights blue, and up here highlights blue. This is what's referred to as scope. This is the body. This is what gets executed. When we were talking about methods, we were talking about taking a bit of code that you would execute, frequently, and moving it into its own little snippet file. Well, the thing that basically says this is the beginning and end of that file, or in this case, the beginning and ending of the method, is the curly brackets. We start it, we write some stuff, and then we close it. Anything created inside there, local variables, do not live outside of the closing curly brackets. So we start dealing with scenarios like down here. Let's say I want to change. I don't want this first one to happen. So I'm going to say false, right? So that turns off this first statement. It's going to come down here, and true is going to come into the second one. It's going to print out second true. So let me finish the debug log else the default, and semicolon at the end to finish it off. So if I run this, I should see the second if printed, okay, which I do right there. And that's because the first statement is false, the second statement is true, and the third statement down here, the else, doesn't actually hit because we're executing this. Now, earlier I mentioned we could chain these things together so we could force logic to happen. This is an example of it. You're seeing it without realizing it. I don't want this second statement to happen every single time, right? So like up here, remember if I set this to true, this first is going to print, but you'll notice that second didn't print. All right, so if I run this, I just get that first if. I did not see the second if or the else, the default, print on my screen. However, if I come along and I instead say that these were like independent blocks. They're just if statements kind of, shotgunned around my scene. They're not linked in any particular order. They're not daisy chained. Then, so here, if I comment this out, but what I'm doing is just commenting out that if, or sorry, the else. I don't want the else. I want the if to just kind of be here all by itself. And we visually will put spaces in to kind of, indicate that there's a separation of logic. So here, this if is independent of this if, but this else is linked. And you'll notice Visual Studio is giving me indicators when I click inside each one of these different keywords. It's telling me like, oh, this else and this if are actually linked. So if I go back up here and I undo this else, the compiler gets rid of white space, so spaces, tabs, that kind of stuff. So it knows that this if, and else, it knows that they're all chained together. So that's why if I put my cursor on any of these individual keywords, they all light up, because the compiler or the environment, Visual Studio, knows that they're all linked together. Okay, but in this case, like, let's say I turn off this else, so now they're independent. This if and else, they're independent of each other. They're not linked whatsoever. So saving that, jumping back to Unity. So if I run this, you'll see I now get the first if and the second if printed, because there's no logical link between that first if and the second if. That's what that else gives us. It stitches those two calls together. That implies that one of those is going to execute, but not all of them. So we can control the daisy chaining, the flow of these particular methods one to the next. Okay, and just like I did earlier, I can invert this true. I can run it again, and now instead of seeing the if, the first if, the second if I run, I should see first if and the else, the default. Okay, so I'll just turn this whole block off because I don't need that anymore. Just give me a split second, looking over my notes, making sure I cover everything, because there's a lot of different little edge case bits of information that go into this stuff. So we've covered the resolves. And earlier I was saying that it doesn't matter what data types you're using as long as they become true or false. Then here in just a minute, we can go through and use some numbers, use some strings, that kind of stuff. So I showed you just a second ago, as I was writing code, I got those squigglies underneath debug. It was warning me that this particular thing wasn't going to be, So what Julio is talking about is over here, when each one of these things pop up at the end of each execution, you get whatever was left over from that previous scene. In my case, I have clear on play set to true. It's enabled. So when I press play again, everything's purged. But if I wanted to start fresh just right off the bat, I could hit clear and it gets rid of everything. It does that automatically when clear on play is enabled, but that's just a helpful little hint there. So if I'm writing code, like I've written debug.log, but you'll notice as I'm typing this stuff out, Visual Studio is already aware that I've only partially written this out. So it considers everything that isn't completely valid, it considers that an error. So you'll notice I have a little red squiggly right down here at the bottom of 32, and also right up here at the beginning, or right after the L. And if I mouse over that, it tells me that debug doesn't contain a definition for L. L is not what I wanted. I wanted the full word log, but I stopped short of it. I wanted to indicate to you that if you're ever working and you're, int x equals 5, you'll notice that the error that you receive from both Visual Studio and Unity when you compile it may not be the line that's generating the error. Int x equals 5 is 100% valid code. The line above it, however, is not. So when you're hunting this stuff down in code, or in a fix me later on, for example, the line that's responsible for the error might not be the line that's reporting. So in this case, if I save, jump back to Unity, you'll notice unexpected symbol int. That's because the compiler, as it runs through your code, it's reading it from left to right, top to bottom, left to right, and it's seeing what it thinks, what it's expecting. And so, like I said earlier, in English, we end a sentence with a period usually. In code, we end it with a semicolon. So by not completing the word, L doesn't exist for starters, but if I was to complete it anyway, it still says there's an error because, again, debug, the class, does not contain L. It contains log, but these are certain rules to writing code. You have to actually finish what you're writing. I have to write out the word log. I have to actually give it the parentheses because it's a method, and then I'm required to actually give it some bit of information. Those are the requirements to satisfy log in this case. And now with those bits of information, yep, exactly. Yellow's a hazard or a warning. Red is an error. So the system will still allow the system will still allow you to compile and run with warnings. Errors it will not. So you have to fix those. But warnings are a good indicator that something about your code might not work correctly when it executes. So you want to instill a sense of treating warnings as errors. There are settings inside your Visual Studio that actually do that, but it's not on by default. But it's a good practice to get into. Just consider warnings errors and go from there. Okay, so that gives you a little bit of a heads up as far as seeing errors in code and possibly not seeing the line that it was actually generated from. So looking back up a line, looking back up a few lines, looking at what the error is actually telling you is going to be very beneficial when you're trying to hunt these things down. Okay, that covers the red squigglies. Now, if I wrote some kind of bad logic, that's what's referred to as a syntax bug. If I was expecting some bit of math to happen, like you guys last time wrote add and multiply and that kind of stuff. Well, if I accidentally wrote an addition instead of multiply and I wanted to know what was going on, Justin covered a little bit about the putting a breakpoint by selecting over here in the, let's see here, and my Visual Studio is going to fight me, so yeah, it's interesting.
I'm not the only person who has Visual Studio's break on me sometimes.
It can do that sometimes, and usually just as a scorched earth policy, just close it.
I've had it to where it wouldn't pull up any of the like when you're typing out something like debug.log, it would never pull up
the IntelliSense database that's tracking all this stuff, that knows debug is a class, log is a method in it, lives over here. When you write it in your code, IntelliSense looks that up and knows about where things live. The problem is it can get confused, especially when you're writing code that it doesn't understand. You can actually cause it to break. So in some cases, it's just good practice. Just shut down Visual Studio and open it back up, and everything should be fine after that point.
I had to do that so many times last fall.
A breakpoint. Oh, what is this? Okay, I'm going to have to investigate this a little Well, there are no errors in this file. I cleared all of those out. But it's telling me that a breakpoint could not be inserted. Why? And there's an ellipsis at the end for a whole lot of no information. Any thoughts there, Lebo? I just tried to add just an arbitrary breakpoint just anywhere in here. Let's try down here. No?
Are you already connected? Are you already attached to anything?
No. Do I have to be? I thought I could do that ahead of time.
I know you can, but sometimes it gets optimized out where there's no code.
Okay. Okay, so let's try. So like I said earlier, you can write, your methods and accidentally break something. The code will compile, which means that it's not a compile error or a compiler error, but the code won't function excuse me. The code won't function properly, which means it's what's called a syntax error, a logical error. So I'm going to go through and let's see here. Much like you guys created the add and multiply methods from last week to experiment around, I'm going to create one that does nothing more than inverts an incoming bool. So this will reinforce a little bit of the stuff you saw regarding methods as well as the inversion stuff. So I want to write a method that, in this case, the return type is a bool. I'm going to call it invert. I want to take in a bool. Let's call it x, doesn't matter. Give it its body. And now notice, just like the errors I was talking about a second ago, this one says not all my paths return a value. It's because part of this signature I specifically said I'm going to return a bool at some point, but I'm not right now. So Visual Studio is like, yeah, you still need to do some more work before you have fulfilled this contract that you said you were going to do. So in this case, I need to return a Boolean. Well, what do I want to return? Well, this method is only going to invert a Boolean. So I know I've got one coming in, x, and I know I want to invert it. And I said earlier that the not, the exclamation mark, is the inversion operator. It's the not operator. So I can do not x to just flip it. So if it comes in as true, it's going to leave as false. If it comes in as false, it's going to leave as true. Now let's say hypothetically I accidentally leave that not off. That would be a logic error. So if I did return x, now it's just taking in and returning the exact same value. So I'll demonstrate for you. Let's see here. Go back up to the top, and I'll take a look at I told you earlier that there was a way to expose variables out to the editor so that you can modify these things in real time. And because update happens every single tick, every single frame, you'll be able to both look at the variable again and then use it live in your code. Yeah, exactly. Computer, work with me. So the way that I expose this kind of information out to the system, number one, I need a variable. Excuse me. I need a variable that's going to stick around longer than the life of one of these methods. So I alluded to local scope earlier when I talked about these curly brackets, and I said that if you create a variable, like here, if I scroll back down and I say Boolean bool b, right? I'm just going to capture. In this case, I'm going to define b as x. X is the incoming variable. I just want to store it. This bit of code has no real practicality other than demonstration purposes. So I'm going to change the x here to b because that's this one that I'm fiddling with here. I don't want to change this x to b. I'll come back and fix this logic in a second, but this is strictly for demonstration purposes so that you can see this is a local variable, meaning that its life exists only between this open curly bracket and this closed curly bracket. Now, I want to modify something in the editor, and so it needs to stick around longer because I can't expose something that's inside one of these methods. I can't expose that out to the editor. So I need to create what's called a global variable. And so if I scroll back up to the top, I'm going to create a bool and just preface it with B, and then just call it toggle. Now by default, the system is going to start it out as false, which that's fine. I want to expose it, so I use a serialize field. And notice as I start typing this, Unity already knows this is also part of the IntelliSense database. It knows what I intend to use, so I can just hit enter. There is no semicolon at the end of this. This is a special thing. It's called an attribute. It just puts a little extra special magic on different variables. 1 second. So 1.3 URL link, which, oh, are you referring to the excuse me, to the Google Doc that's in that zip? Yeah, that really shouldn't be in there. You could ignore that. The two critical pieces of information we'll get to in just a second is the Excel sheet, which contains all the bugs, the bug listing, as well as the file itself, which is what has the bugs in it that you're going to be modifying and fixing. So yeah, we'll deal with that in just a second. So here, I've exposed it to the editor using this serialized field. Bool, I'm just going to call it btoggle, and down here, I'm just going to say debug.log, excuse me, value of btoggle is btoggle. Okay, so at the moment I'm not using my invert, but I just want to make sure that this first little bit works. And there. Now, mind you, Unity's editor, the inspector over here, it looks at the variable that you've written at the variable name, and it kind of tries to modify it in different ways. So that's why it doesn't look like the same thing that I just wrote. But you're free to ignore that. So if I start running, update over here in my code, you'll notice it's printing over and over and over and over and over again. And so if I turn it on, it's now true. If I turn it off, it goes back to false. Okay? So now, so I have the value of toggle. I'm going to copy that line. Whoops. I'm going to copy that line. And I'm going to say the inverted value of toggle. And now I'm going to call the method invert, but I'm going to pass it the value btoggle. So invert, if I spell it correctly, that would help. Okay, so now if I run this, you'll notice we should have the exact same thing. The inverted value, currently it says false, and now it says true. This is a logic bug. I've written wrong code. So to sort this out, I could go through and apply the breakpoint like you saw in the last lecture, actually attach to Unity, one of those two, and then step through and inspect each one of these values and see, like, did B come in as true? Sure. Did B get returned? And I could look at the information being printed out here and see what was actually going on. So in this case, I know in this very simple example that it was just this invert code that I had commented out earlier. So I can just flip that over, flip those comments over, save, jump back to Unity, let it compile, play. And now the inverted value of btoggle currently says it's true because up here we're false. If I go to false, or if I go to true, now it becomes false. So we can see that I'm passing that information through a number of channels. I'm calling invert, giving it toggle, which I'm controlling globally, and then it up here captures the value, inverts it, and then returns it, which is then printed out down here at the bottom. So we already pretty much covered this stuff with inverting the characters. Now, we'll look real quick at the Scoville scale stuff. And if you, for those of you watching the recording, you guys in class, you can take a look up here. The coloring here is a little wacky, so let me change this to C#. So it'll kind of pop a little bit more. But you can see, in this case, and your week 2 project, I know I'm running short on time, that's why I'm kind of speeding this up. The week 2 stuff is going to ask you to go through and respond to button presses and that kind of stuff. And here's an example of what it's kind of asking for. Using the if on it, just like debug log, we also have another class from Unity called input. And we have a couple of different, we have a number of different methods that are inside it. But like if you wanted to poll for a single key every single frame, is it pressed every single frame, yes or no? That's what getKey does. Notice I use shift here as a modifier. Now, if I want to check just one single time that it was pressed down, then it stopped responding. That's where getKey down is. That's a single instantaneous click. And I could use that. I could chain that together using the ampersand here to say if I have pressed and held the shift key, which here we create a local variable called shift, shift held, that kind of deal, set it to false. If we're holding shift, we set it to true. And down here, like I said earlier, we can chain these things together, true on one side and then true on the other. If both the A key was pressed once and we're holding shift, then we can debug log A. Let's see here. We just discussed the global variable versus local variable, being able to change it in the global scope. This was kind of the example I was using throughout the course of the lecture, talking about whether or not the door was locked. If we had the key, we could do things. This goes further into detail. This little block right here talks about how you can daisy chain these things together. The second, line number 57, the second if check is actually linked to the first one by use of that else keyword. So those things are dependent. You're going to run the first one or the second one or the third, so on and so forth. But notice the next line down from 63 down to 70, or rather 69 right here, these aren't chained. There's no linkage else. There's no linkage between each one of these things. So you can actually control the order, but it's worth keeping in the back of your mind that if you're doing logic checks, if you're doing rules, checks for rules, you might need logical chaining so that they don't flow one to the next. If you're asking if I have, if I have the key and then the very next thing says do something with the key, that's fine, but you excuse me, you might have wanted to do some kind of extra thing, maybe trigger some kind of an animation, maybe print something out. And if your final response was expecting, step A, then step B, then step C, but you in your code went from step A to B to C in one fell swoop, then your output would look differently. So again, these things, they vary depending on what kind of problem you're trying to solve, what kind of gameplay you're trying to create. Yep, exactly. So here, what I'm about to do, just real quick to scan over the Scoville scale stuff, the Scoville scale stuff. There's a video in I think it's question number 10 that shows you all this stuff. It's like a 20-something, 28-minute long video that you can burn through. That'll show you the different comparisons of each, or different uses of each one of these comparisons. Now I'm going to go through and very quickly show you just like the very basics of what the Scoville scale actually would contain. This is your test. This is the first test 1.3. Now let's see here. The website is actually linked in the test itself. I'm not going to go into it because it actually would show you answers and whatnot. But if you just Google Scoville scale, the first link to the Wikipedia article, if you scroll down, see here, this set of ranges right through here along this left column are what we're looking for in the test. So if I jump back to my code, I'm going to go ahead and I'm going to turn the whole block up. Actually, I'll tell you what. I'm going to jump back to Unity. I'm going to turn this script off completely. Create a new one down here in my project. Call this Scoville scale example. Reload that solution. And I actually need to apply it before I can use it. So just outside of that real quick, I want to paste in the code that I just copied over. So it's going to look ugly for a split second while I show you what's actually going on here. So we mentioned earlier in the last file that these two, your serialized field is a global, and then the variable that you would be modifying in the inspector would also be a global. So those two would be above the start and update up here. Now I don't actually need start because I don't need to do any kind of initialization. I already set it up right here. Update, I'm actually going to just recreate right here. Just add my void, open to start the code block, and then right after all of it, add the closing curly to end the code block. So this is the exact same. It's giving me an error here because it's detected multiple updates, and it's not allowed to have that. Not allowed to have multiples of the same name without doing some kind of override or overload, whichever. So I'm going to get rid of the start and update because I don't need them, and clean that up just a little bit. So the code that you're being asked to look at inside that test 1.3 question number 11 basically runs through the Scoville scale as it exists as far as ranges. So we have a minimum and we have a maximum. Now taking a look at the Scoville scale over here, you'll notice, and again over here, over here in the lecture slides, starts at let's see here, 2,480,000, and then 855,000, so on and so forth. So running down through this list, you'll notice anything above 2,480,000 is the peak of this scale. If you had hotter peppers, it would go above that. But you'll also notice that these numbers don't necessarily converge. The 855,000 and 580,000. There's a gap between those two. And that's just how these peppers were determined as they, went through, and I guess there's a range between those two that doesn't exist. But in any case, so you're asked to look at each one of these ranges. Now over here in the code, we're looking at the heat value as it compares to some minimum and some maximum. Now I want to know if my heat is higher or equal to the minimum or less than or equal to the maximum. So in this case, heat here is my choose your heat. So I'm going to copy that and just paste it in to my two heat values. There are 10 levels on the Scoville scale. So between the line that I just wrote and the wuss down here at the bottom, there are 8 more levels. So if you've got more than that, you probably should look closer at your code. The instructions ask you to write just some kind of a snarky comment. I think the one that's in there is like, oh God, why? This one is, oh, Hephaestus, why? He's the Greek god of fire and volcanoes. So the min and the max in this case, if we come through, we can just snag these values. And this, actually, let me go with the top. Pretty much. And now we don't deal with commas, so we can scrub those. We can scrub those 3 commas. And if you double click, it'll highlight it. So my minimum in this case is 855,000, 2 million and some change. So my minimum is this 855,000. My maximum is the 2 million. So I can just paste that in, triple click to highlight the line, and get rid of it. And so now, if I save, if I take this number and I go one higher, and save, jump back to my code, or jump back to my Unity, excuse me. You'll notice it's updated over here. If I run, it should say wuss, because it's outside of the range of all my checking. Therefore, the default else, which says wuss, is what's triggered. Now, I can modify it here. I can punch in an actual value. Or if you mouse over the word, the variable name itself, you notice you can click and drag, and it can modify what's actually being printed. Most of the stuff in here will do that, like the X, right, for the position, that kind of stuff, but not over here because it's 3 components. So in this case, I've dropped it below the 2 million mark, so snarky comment is what's being printed. So this is essentially what that test 1.3 question number 11 is asking you to do. Go through and further realize what's going on with the if, and actually this top one would actually be the maximum value. Again, if you glance here at the 855,000, but actually that's a bad example because it doesn't actually include the top range. So anything above 855 exceeding 24.8 would also be included here, but you might want to cap it at a top. You might want to have some kind of a, this is off the charts if you go above 2 million and some change. So you can totally do that. And the idea would be the right here, else if for 8 more. Okay, so to wrap this up, let me do a real quick look at the fix me, and then you're good to go. So over here in the in FSO, underneath the week 1, you have 2 test 1.3s. The first one, like I just mentioned, you go through, you fill that out just like test 1.1 and 1.2. Test 1.3 turn in, you have this set of instructions on how to name the stuff that's inside it, how to create the folder. This again being a brand new project. So I'll jump back over here to Unity. I can go ahead and do File, New Project. I'm going to name this like Fix Me Example. Drop it in my sandboxes. I don't want analytics. I don't care about 2D or 3D. In this case, do I want to save this scene? No, I do not. Okay, there's a zip that's attached down here at the bottom. When you download this, yeah, my apologies for this gigantic resolution nonsense going on. That's just atrocious. So when you download the file that's associated with this thing, you'll notice the instructions go through and tell you to create, PGF projects folder, open the Fix Me down below here. If you don't have, excuse me, you should be on Windows. You should have everything through on the hub or whatever. If you don't, if you need like an Excel viewer, just Google Excel viewer and it'll take you to Microsoft's download page. And from there, you can download not only the, if you do download, you can also turn this nonsense off that they want to install all this other crap. But you can also, if you wanted like a Word viewer, PowerPoint viewer, you have the ability to read this document even if you don't edit it. Which in this case, all we need you to do is just read the content. So pull that zip, decompress it, and go looking through this the instructions here. It's going to tell you stuff to pay attention to, stuff to watch out for. Again, this is just covering the lecture material that we've done from days 1, 2, and 3. So Pay very close attention not only to the information that's in this document here, also the stuff that's in that Excel sheet, but also please read the code and the comments that's actually in the file. It's right there. And then when you're all done, down here at the very bottom, it talks about how you would go about submitting this thing. Now, the file, this zip, when you pull it, okay, so this file, when you download it, view it on your file system, expand it. Actually, I just went into preview mode. I don't want to preview it. I actually want to extract it, so extract to here. So inside this folder, ignore this double underbar Mac OS folder. Ignore all this extra stuff that's created up here at the top. This fix me that Julio was talking about a minute ago, ignore that. Sorry, this Google Doc, GDoc, ignore that. So you specifically want to concern yourself with these last two files. This Excel sheet, if you open it up, it tells you where when this thing was originally created, where Unity reported to us the error existed at the time. Now again, like I mentioned earlier, what is being presented to you as the error might not be the line that it's generating from. It also, those two numbers inside the parentheses, 25 and 1, 27 and 8, that's the vertical line and the horizontal line. Vertical offset and horizontal offset of where this thing exists. So it's going to be pretty close to that location. And then over here on the in the columns, or in the comments column, it's going to give you a little bit more information about what's going on. So all you need to do is go through and hunt down and fix these first 5 issues. The reason I say first 5 is because I'm going to give you 6 and 7 here in just a second. So inside this zip as well, I have this last name, first name, underscore fix me 1. Now, if you remember over here in the documentation a second ago, I said it had some submission stuff. You will replace the name, that's what I'm about to do, in both the script and the file name. The reason for this is the class name must be identical to the file name. If they're not, Unity won't allow you to attach. It has to do with the way the engine looks at mono behaviors. It has to be able to look up the name, so it's just a requirement of the engine. So when you go to submit this thing to the to that particular test 1.3 turn-in submission box, you'll want to take your first name, last name, the file 1, find it in Explorer, zip it up, and then submit that. That's what we'll be grading. And like I said, we'll be grading based on what the fixes should be, even though the grading thing says whether or not it plays or not, 100% pass fail. Correctly in this case means if the code was fixed correctly. So it may run, it may not manifest any kind of errors, but if your fix isn't what it is supposed to be, and again, read all the documentation, read the comments, the code, everything, it's all available for you. Again, open book, reference these slides in this video, reference, actually look these things up or whatever, Google, what are comparison operators? If it says one thing, what does that mean? Look up and verify. It's open book. It's 100% or not. That's about all I can do for you. Don't go rewriting whole mass sections. Don't try to brute force this thing to just make sure that it works, because we know, we'll look at the code. We difference this against a proper version, and if they don't match, then it's 0. So, okay, so I've got my Unity project down here, and now I want to drag that fix me. All right, so I'm going to make a copy of this thing. Jump back over here to my Unity project. Right-click inside the project view. Go up to Show and Explore. Inside this folder, I want to go inside the Assets folder and paste. Now, as soon as I go back to Unity, it's going to start screaming bloody murder. It doesn't understand what this is, and so on and so forth. These are the showstopper errors that you see inside that Excel sheet. Now, to even get it running in the first place, it's got to be error free. But initially, bugs number 6 and 7 from that list, you need to go right here into your project, and just so you can see it, it's right here under assets. Change over here inside Unity. You can either, with the file selected, click one more time, kind of a long press click, right? It'll go into edit mode. If you don't, if you haven't selected the one time, you should also be able to hit F2 on your keyboard, and it will go into edit mode. In this case, I want to rename it to last name, first name, so Reynolds Tony, and then get rid of all this extra stuff, but leave the fix me one. Now, I need to open that file. And you've got a couple of options here. You can write this again and risk the potential of accidentally spelling it wrong and scratching your head for a while trying to figure out what's going on. Or you can also come back over here with it selected, click once, or hit F2, copy, just Control-C to copy the text that's right there, jump back to Visual Studio, double-click this line to get just this whole word, and Control-V to paste. Control-S to save. Now jumping back to Unity. Assuming there were no bugs, I should be able to take that file, attach it to the camera, the directional light, a game object, whatever, and run this thing. The way this particular project works, if you'll notice, as I scroll down through here, this is a number guesser. In your mind, you come up with some kind of a number, and when you start playing this in a range between 1,000 and 1, you basically use the up and down arrows to find or have this program guess what your number is. So you say it's higher or lower, and you eventually narrow in using a half space test that divides or whatever to get to your number. So to do this, it's going to be printing this information out to your console. So again, notice for these very simple projects, we're using debug log and debug log here, as well as debug log in a number of other locations. So what will end up happening is when this thing actually does start running, functioning correctly, you'll see this information printed out down here. Now, it's also worthwhile to pay attention to these. Like in my case, I have it collapsed. So when I have this code working correctly and I get the program to guess my number and I say I want to play again, it will loop back around. And so the stuff that was printed out at the top, like, do you want to play a game? Excuse me, will start counting up again, even though it's got other information. So you could stop playing, you could hit clear and keep playing it that way. But it's worthwhile to note, if you have collapse on, it'll do that. You can turn collapse off and you'll still get all this stuff streamed to your console. And so basically, above and beyond that, all you need to do is go through the green lines of the comments. They will tell you certain things to do or what the code was expecting. And so based on the stuff that we've given you in the first 3 lectures, you should be able to identify where different issues are in here. If it feels odd, like I don't think I should be editing this particular line, it doesn't seem like this is a fix, then trust that instinct, because you probably are modifying code you shouldn't be. But again, follow the information over here in this documentation. There's a lot of good information in there as far as debugging. Every so often, let's see here, there's this note here. Note that you may run into other issues after you fix issues. The rationale behind this is bugs tend to snowball. They tend to cascade throughout your code. So you always start with the top one, work your way down, because you could very easily fix that top one and suddenly you no longer have an avalanche. Everything else is just fixed right after that. So when you fix one thing, save, jump back to Unity, see what the compiler, what the console, what those errors are, and then go from there. Take a look at the additional information that is presenting to you. Try to match that up with that document, the Excel sheet, and go from there. So unless there are any further questions from here, you're basically free to work on that / free to go, I believe. Yep. And I'm going to answer questions over here in the chat. So any questions, comments, concerns? Awesome. Yeah. Whenever you run into something, need a little bit more clarification or further explanation or whatever, just fire away. Yeah, as Julio points out, when you actually start playing this thing, it's going to print out a whole bunch of times to your console, do you want to play a game? That's because it's in update, it's calling log, and it's just printing. So if you did collapse, you would see it one time, but over on the side, that little counter bubble would sit there and count up, 500,000 times plus. And it's just waiting, excuse me, it's just waiting for you to press yes or no. So you have that kind of thing to just be aware of. Cool. Okay. 717 went over just a little bit. Cool. All right. I'm going to stop recording here because I think that's basically covered. Let me glance at my notes one last time just to make sure. Yep, looks like everything was covered. So I'm going to stop recording.